Okay, so it says here that we need to simplify each of the following. So yesterday we had gone over factoring because whenever we are multiplying, dividing, adding, subtracting radicals, a lot of times it's going to be easier for us to do that if we factor first because we'll have a lot of things that will divide out. So first thing we are going to do is factor every piece that we can. So this piece right here, 2x squared minus x minus 3. So if I'm going to factor that, I look at the 2x squared piece first, which tells me to use 2x and x to start my factors. Then whatever I put at the end has to multiply to give me -3. So I know I want to use 3 and 1, and it has to add to give me -1 right here. So I'm going to need to put the 3 here and the 1 here because this would give me 3x and 2x if I multiply here and here. And as long as the 3x is negative and the 2x is positive, that would add to give me -1x. In the denominator here, I can factor out an x as a GCF, which would leave me with x plus 1. And then over here in the numerator, I can factor out a 4x, which would leave me with x plus 1. And then the denominator, 2x minus 3, does not have anything that can factor out of it. And now that we have factored, before we actually go in and multiply, there are quite a few things that should divide out for us. So we've got 2x minus 3 that will divide out. We've got x plus 1 that will divide out. And then this x right here will divide out with this x over here, which means all we're left with in the numerator was the 4 right here that was in front of x, followed by that parenthesis, x plus 1, and everything in the denominator divided out to 1. So all we are left with is 4 times x plus 1. So we actually didn't end up having to multiply anything because everything divided out for us. So let's do another one of those. Okay, so again, I'm going to factor everything I can, starting with that x squared minus 4. That's a difference of squares, so that's going to be x plus 2 and x minus 2 over that 2x minus 5x plus 2. So this 2x squared tells me to start my factors with 2x and x, and it has to multiply to give us 2 and then add to give us -5. So I'm going to want to put the 2 here and the 1 here so that when we multiply here we get 4 and here we get 1. And 4 and 1 can give me -5 as long as they're both negatives. Now, this one does say to divide. And remember, if we are dividing fractions, what we are really doing is multiplying the first fraction by the second fraction's reciprocal. So we use a rule that we call keep, change, flip. So I'm going to keep my first fraction in the order it's currently in, change to multiplication, and then I'm going to flip this fraction over. While I flip it over, I'm also going to factor it when I rewrite it. So this is now going to be in the numerator, which is a difference of squares. So that's going to be 2x plus 1 and 2x minus 1. And then in the denominator, we now are going to have this piece, which would factor to 2x and x, has to multiply to give us -2, add to give us -3. So I'm going to need to put the 2 here and the 1 here. So this would give me 4x, this gives me 1x. As long as the 4x is negative and the 1x is positive, we would add to get that -3x. All right, now just like last time, before we even actually multiply, we should have some things that are going to divide out. So it looks like we have x minus 2. We've got 2x minus 1. And we've got 2x plus 1. So now all I'm left with in that numerator is x plus 2 and all I'm left with in the denominator is x minus 2. There's nothing that I can factor any further or simplify, so that's where we stop, and we ended up, again, not even actually having to multiply because so many things divided out. All right, let's look at example number 3. On number 3, we are being asked to add these fractions, and remember, if we are going to add or subtract fractions, you have to have a common denominator. So, I need to figure out how I can make these denominators the same. So, I could turn 2 into 4 by multiplying it by 2. So I'm going to multiply this by 2, but we know that the rule says if we multiply our denominator by something, you also have to multiply your numerator by the same thing. So if we multiply here, we got 2 times 1, which is 2, over 2 times 2x squared, which would be 4x squared. Okay, so now they both have a 4, but this one has x squared while this one just has x. So if I want a common denominator, all I would need to do is multiply this by x so that it will have x squared. But if I do it in the denominator, I have to do it to the numerator as well. So here I've got 5 times x over, here we've got 4x squared. And now that these have a common denominator, we can go ahead and add the fractions. Remember, whenever we add or subtract fractions, we only are dealing with adding and subtracting the numerator. We leave the denominator alone. So we'll have 2 plus 5x over 4x squared. In this particular case, I cannot factor the numerator or denominator any further, and there's nothing that is going to divide out, so that is where we stop. All right, number 4. So on this one, we are subtracting. So again, we are going to need a common denominator. Okay, so the denominator for our first one is x plus 6. Let's go ahead and factor this denominator to see if they have anything in common at all. So here, we need something that's going to multiply to give us negative 12 and add to give us 4. So that would have to be x plus 6 and x minus 2. So it does look like these fractions have x plus 6 in common. So that means the only thing this fraction's denominator is missing is x minus 2. So I'm going to multiply by x minus 2. But if we do that in the bottom, we got to do it in the top as well. All right, so now we need to multiply these two terms together in the numerator. So I'm going to have x times 2x, which would be 2x squared, and x times 3, which would be 3x. And then I have to multiply the negative 2 times 2x, which would give me negative 4x, and negative 2 times 3, which would give me negative 6. All over that common denominator of x plus 6 times x minus 2. Minus that second fraction already had the common denominator, so I don't have to change anything about it. So it just stays x squared plus 3 over that common denominator of x plus 6 times x minus 2. Now that we have the common denominator, I can put this all together. So it would read 2x squared plus 3x minus 4x minus 6 minus, now we have to be careful here. Remember, I'm subtracting this entire fraction. So that minus is going to go with the x squared, but it also distributes over here to that 3 as well. And this is all over our common denominator of x plus 6 and x minus 2. All right, so now I'm going to combine like terms. I've got 2x squared and negative x squared, which would leave me with x squared. I've got 3x and negative 4x, which would give me negative x. And then I've got negative 6 and negative 3, which would leave me with negative 9, all over that common denominator of x plus 6 times x minus 2. If possible, we would like to factor what we have up here, this x squared minus x minus 9, but it is not possible to factor that as there is nothing that's going to multiply to give us negative 9 and add to give us negative 1. So that would be our final answer. All right, for number 5, again, we're adding and subtracting, so we need that common denominator. So I'm going to factor what I've got over here first to see what we have in common. This is a difference of squares, so this ends up being 2x plus y and 2x minus y, which each one of these fractions have something in common with. So here we're just missing the 2x plus y, so I'm going to multiply this fraction by 2x plus y in top and bottom. And then this one is missing 2x minus y, so I'm going to multiply numerator and denominator by 2x minus y. So we've got 2x times 3x, which would be 6x squared, and then y times 3x, which would be 3xy, over our common denominator of 2x plus y times 2x minus y, minus, for the second fraction, we got 2x times 2x, which would be 4x squared, and 2x times negative y, which would be negative 2xy, all over our common denominator of 2x plus y times 2x minus y. Plus, over here, we've got our final fraction that already had the common denominator, so I don't have to make any changes to it. And now that we have that common denominator, we can go ahead and add and subtract. So we're going to have 6x squared plus 3xy. Again, whenever I subtract, make sure I remember to subtract both of these pieces. So it would be minus 4x squared plus 2xy, since that 2xy was already negative, plus that 2y squared in our last term, all over that common denominator of 2x plus y times 2x minus y. Now I'm going to combine like terms, so I got a 6x squared and a negative 4x squared, which leaves me 2x squared. I've got a 3xy and a 2xy, which gives me 5xy. And then lastly, I've got my 2y squared, all over our common denominator of 2x plus y times 2x minus y. Now that numerator should factor, so that's what we're going to do next to see if we can simplify this any further. So my first term is that 2x squared, tells me to use 2x and x. And then right here we've got 2y squared. So 2 and 1 both need to have y with them for that y squared. And it's supposed to add to give me 5xy. So I'm going to need to put the 2 here. So that way when I multiply it with the 2x, I'll have 4xy. And I'll do 1y here so that 4 and 1 can add to give me 5 as long as they are both positives, over that common denominator of 2x plus y, 2x minus y, and our 2x plus y's will divide out. So all we are left with is x plus 2y over 2x minus y. I can't factor any further, so that would be our final answer. All right, number 6. Here we are subtracting and dividing. Now, in order to subtract, we do have to have a common denominator. So currently, this is x, or x over 1. I can easily turn that 1 into an x by multiplying it by x to get that common denominator. So in top and bottom, I'm multiplying by x, which is going to give me x squared over x minus 1 over x. All right, and then in the bottom half of this fraction, we've got 1, or 1 over 1. And again, our common denominator is going to be x, so I can multiply this fraction by x, which ends up being x over x minus 1 over x. And now that these have a common denominator, I can put them together. So it would read as x squared minus 1 over x over, I can put these together as well, x minus 1 over x. This can be factored, so I'm going to write that as its factors. It's a difference of squares, x plus 1, x minus 1 over x. And remember, when we divide a fraction by a fraction, we keep, change, flip. So I kept my first fraction's order the same. I'm going to change from division to multiplication, and then I'm going to flip this fraction over. So now it's x over x minus 1. And again, we have a few things that are going to divide out for us. So x minus 1 and x minus 1, x and x. And all we are left with in that numerator is x plus 1, and everything in the denominator divided out to 1. So our final answer is x plus 1. Something I also want to show you is that it just so happened that we were choosing to find a common denominator for both this piece and this piece that was the same. We call that a least common denominator. So another way you could have solved this would have just been to multiply this original piece right here, x minus 1 over x times x, and then do the same in the bottom, x times the original 1 minus 1 over x. If you did that, you would just distribute x here, and you'd have x minus x over x, and x over x, anything over itself, is 1. X squared minus 1. Over here, I'd have x minus, again, x over x. Anything over itself is 1. As we said before, that was a difference of squares, so that factors into x plus 1 and x minus 1 over that x minus 1, which divides out and leaves us with x plus 1. So either way, we would end up with the same solution. All right, last example. For number 7, again, we're adding two fractions up here, and we need a common denominator between x squared and x. The easiest way to do that would be to multiply this by x to make it x squared, so I have to do that to the numerator as well. So that first fraction was 3 over x squared plus, once we multiply, we have x over x squared. In the denominator, our common denominator is going to be 5x. So this is 2, or 2 over 1. So I'm going to multiply it by 5x. So here I would have 10x over 5x minus 4 over 5x. So now that this has a common denominator, I can write it as 3 plus x over x squared. And when we divide a fraction by a fraction, we keep, change, flip. So I'm going to keep that one. I am going to change to multiplication. And then I'm going to flip this fraction over. So now the denominator 5x is on top. And we have 10x minus 4 on the bottom. So here we don't have a ton of things that are going to divide out, but I can divide out this x with one of these x's. So that 2 is now just a 1. So we are left with 3 plus x over x times 5 over 10x minus 4. So since not everything divided out, we are going to actually have to multiply here. So I'm going to have 3 times 5, which would be 15, and x times 5, which would be 5x, over x times 10x, which would be 10x squared, and x times negative 4, which is negative 4x. I could factor out a greatest common factor between these here. So in the top, my GCF would be 5, which would leave me with 3 plus x. In the denominator, my GCF would be 2x, which would leave me with 5x minus 2. But I am still unable to divide anything else out or simplify any further. So these two answers are equivalent and either one would work.